should you buy stock in Monster Energy? Don't know what stocks are?
Yeah.
Okay, cool. Good. All right. So stock prices, look at this. We went from 275 to 4501 in the span of from 2006 to 2022. Okay. So really quick, we talked about yesterday residual, the word residual. Okay. Residual is the difference between the actual minus predicted. Yes. Okay. So oftentimes it's going to be represented by this little arrow. So you see how this dot is kind of close to the line. It's finding the difference between those.
Oh, so now we're into those boxes, right?
Yeah. How do you know?
Huh?
How do you get that? How'd you know?
Because it's
Thank God. Okay. And we can draw a little box to help us see the residual. Everybody say residual. Good job, class. We're drawing just the little boxes. Okay, now here's the hard part. You see how this dot's like crazy over here? All right. Well, this line actually extends. And if you like continue it on, that's a big difference. Yep, 2006 be crazy. Okay, is
oh, wait, you don't go above thing.
so what line is this called? Least square
That's why I couldn't do it yesterday.
regression line. Least square regression line. Remember our little acronym? We said LSRL. I said, you got to memorize this, right?
Oh, I didn't hear that.
Yes. Okay. Everybody good? Now, the little boxes that we just drew, are the residual squared. Haha, because it makes a square. Y'all are so great. Little arrows is just the residual. So when we draw the box, that's the squared part. When we just draw the arrows, that's the residual. Okay, so just like what Mo was saying, we got actual minus predicted. Cool. Wait. Go ahead.
Run it back a little bit.
Okay, residual is little arrows. It's the difference between the line and the dot. The residual squared is when we draw the box. Yeah. Okay. Good. Good. Okay. So describe the form of the relationship. Looking at the dots. No, form as in like, is it quadratic? Is it linear?
Linear.
Look at the dots.
Oh, wait, it's exponential.
Okay, so we're not really like we don't have the equation for it. So we're gonna call it non-linear. So the dots are non-linear. Everybody see how it's like a swoosh if you like actually connected all the dots. Okay, non-linear. Good. However, the least square regression line is what tries to linearize it. Okay. Same. Yeah. Remember, stat be doing the most. Okay. Use the regression line to predict the stock price for 2010, then find the residual. Okay, so what was our what? No. All right, so what was our regression line? Look up at the graph, it tells you. It says y hat is equal to negative 5,608 plus 2.7938x. What are we going to stick in for x? Lord. What are we trying to find? No, not 3.68. So we're gonna plug in 2010. Yeah. Okay. Go ahead and do that and tell me what you get.
Mo, shut up.
Like in most of these videos, there's just a line that's like Mo, shut up. I'm like 99% sure.
Watching it, I think it's so funny.
Yeah, I don't believe it. All right, so you should have gotten 7.54. Yes, no? Okay. So now to find the residual, here's the important part. Pay attention. To find the residual, we're going to take what was in the chart, which was 3.68, and we're going to subtract what we just predicted, which is 7.54. So that's going to give us a difference of negative 3.86. So just like what Mo said, we're going to do the actual minus the predicted. Gucci. Okay. I want you to try number 3. Same thing, different number. Same thing, different number. Gonna take a moment. Was it what? Negative 3.68. 5,688. Yeah. So when you plug that into your calculator, you should have gotten 41.06. 41.06. All right, and then when you want to find the residual, you're going to get 41. Ooh, back it up. 45.01 minus 41.06. When we plug that in, we're going to get 3.95. Is everybody okay with finding the residual, finding the predicted? Did you say no? God bless Mo. What?
Yeah, why are we doing 35.01? Is that what we?
That's in the table.
Yeah.
So actual minus the predicted. Actual, which is in the table. That's what we found. Minus the predicted, which is the regression line that we plugged in.
What is it? 3.95?
3.95. Questions? Mappa's so lost.
I don't know.
Okay. Sure. Okay. Now, how can we find the prediction for this guy? Looking at the little table below, in 2010, there's missing pieces right here, right? So what are we going to do? We're going to plug in 2010 into our equation. So go ahead and take a moment. Try that one. You're plugging in 2010 into the equation. Into the equation that was above. Gun silence is very reassuring.
Let's go from water.
Believe it. All right, so you should have gotten 7.54. And then if you subtract actual minus predicted, you're going to get negative 3.86. For the next one, it's 41.06. If you subtracted those two, you're going to get 3.95. Okay, so now we're going to graph the residual. We're going to graph the difference between the actual and predicted. Okay, so when we do that, we're going to take this last column and plot it. So we got this point, we got this point, we got this point, this point, that point. Oh, if it is above the line at 0, then that means that the actual is greater than the predicted. If it's negative, then that means that the actual is less than predicted. So for which points was the actual stock price greater than the predicted? So what 4 years do we have where it was greater than?
2006,
What about less?
2010, 2012, 2014, 2016, 2018.
Okay. Does the residual plot have a pattern? I like a W. So yeah, it has a pattern. It has a curved pattern. And we can't really call this a quadratic. But it is U-shaped. Done. Because it went from plus to minus to plus. The linear model may not be the best. If the residual plot has no pattern, then the line is a good model. So just a side note, if no pattern, line is a good model. What? Oh. All right, go ahead and flip. Is a good model.
Miss Emily, have you looked to your house? Yeah, but like last time we looked the story with the dollars.
Big dude, homie. Big dude. All right. LSRL is the least square regression line. I'm not writing that again. And it minimizes the sum of the squared residuals. He's also from like South Georgia, and everybody down there is like
Does he have that big country accent?
Yeah, he sounds like cornbread.
You know, like actually.
Yeah, he is, yeah. It's awesome. It sounds like honey and cornbread all mixed together.
What type of country accent? Because there's different types.
Not bad. It's not bad.
It's not,
Give us your impression.
like,
I don't have an impression of him.
okay, like name like a celeb, like a country singer that sounds remotely like.
One day I will play music because he actually plays the guitar and sings. So yeah, I know. I know. Full country dude. Yeah, I did. Did you say he's the perfect male? That I'm telling him. All right. So good scatter plot has crazy dots. Bad scatter plots look like a quadratic. Or looks like a absolute value type thing going on. Because it's not a linear model then. We don't want non-linear. Like this scatter plot, I can draw a straight line and say, hey, it's trending this way or this way. With this, it's not. It's a quadratic. It's not predictable as much.
I'm so confused. Why is it top right one day?
Oh, because I can't draw.
Oh.
It's got like an absolute value type, like parabola sideways kind of thing. Okay, so no. Fueleconomy.gov gives the city and highway fuel economy for many makes and models of vehicles. The scatterplot shows the city and highway fuel economy MPG for the random sample of 9 vehicles. Oh, okay. So describe the relationship between the city and the highway fuel economy. So we have like a little acronym for this. It's called DUFS plus context. So this stands for, always forget the U. Direction. It's like up or down, function, and give me a second for the S. Maybe. So what we're going to say is this is moderately strong. Moderately strong. Is it positive or negative? Good. Is it linear, quadratic? Is it linear or not linear? Linear. Following that trend, right? It's close to that line. Yes? Okay. Linear.
How is the other one not
Because it went like this.
the other one was
Hey, look. No, look. It went like this.
but it falls in line. That's going. This one is going like this. Yeah, and it's still falling line.
It's still following a trend. It's kind of like can you put your hand in between, like, can all the data points fit this pattern? Look back at the last one. Look back at the last one.
No.
Say again.
Literally, like, we'll also press out other lines to see it goes like, and like.
And when it comes to line of best fit, when actually that's all.
It's 0.85.
Strongly correlated.
Like, but the thing is, also when it comes to line of best fit, like, you know that it's good when like there's like a rough even amount of dots on both sides, and that fits out to. So you.
I guess you could probably make an argument for that linear as well. Okay, let's move to the next part. So, what is the context on this one? What's the context on this part? Okay, so between the city and highway fuel economy. And do we have any unusual points? Do we have any like outliers or like crazy things out there? No. Okay, so no unusual points. Okay, so now we've got to write the equation for it. This is your A, this is your B. These are your coefficients. They already did the work for you. So your equation on part B is going to be, for part B, it's going to be the highway fuel economy. I'm just going to write this down farther. Give me 1 second. So we got highway fuel economy plus, make sure that you put like a little hat on top of it. And then what is your y-intercept? Well, that's going to be 1.151 plus 1.469 times the city fuel. Explain what it means by least squares regression line. Remember, this is the line that minimizes sum of all squares residuals. Residuals. Okay. What does the residual plot indicate about the appropriateness of the linear model? The residual model, does it have a clear pattern or is it randomly scattered? It's randomly scattered. It still follows that trend. Okay, so it's randomly scattered. No clear pattern. Okay, which means that the line is good for making a prediction. It's not, oh, I go up 3/1. When I'm talking about like that kind of pattern. Like it's not sequential, like, hey, without that line of best fit, what's the next dot? Does that make sense? Yeah. What does the S stand? We okay? Direction, unusual features, form, and strength. Wow. All right, so Duff's is direction, unusual features, like outliers or clusters, form, and strength. Okay, so direction, is it going up or down? Is it have any outliers? Is it linear, nonlinear? And how strong is it? So that's what Duff's stands for when we talk about describing the relationship. Okay, I'm with you on the front. Go back to number 1 on the front page. Go ahead and change that to linear. I concur.
Thank you.
You're welcome. Number 1 should be linear. Because there's not like a real good reason. It's close enough to that line. It may not be the best it may not be the best line though, because of the residual. So looking at the residual, we get a U shaped. If we look at the residual on this one, that's still kind of random. So it doesn't have like a U shape. Because remember, U shapes are bad.
Correct.
We want scattered residual.
Yes. And so because of the residual of the first, like, thought, you can't, like, because of that, then the line wouldn't be fast. Or we're looking at, you can't not say that that's.
It's a linear progression, like how it kind of travels.
Right.
Basing it off of the residual, which is where you determine whether the linear model is good for it or not. Wouldn't be best for it. Does that make sense? Okay. All right. So now comes the time.